Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So in this video you are going to learn about differentiation of hyperbolic functions. This slide shows the derivative formula for hyperbolic functions. So these are all the hyperbolic functions and its derivative. For example here, the derivative of sine hyperbolic of x will be equals to cos hyperbolic of x. And for the derivative of cos hyperbolic x is equals to sine hyperbolic of x. So you can pause this video and see all the formulas for each of the hyperbolic functions. So now let us proceed this example to find the derivative of the following functions with respect to x. So basically, in order to solve the derivative of a function, it's just all the same, okay? It depends on the function. It depends on the equation itself. Let's say the equation have a product of two functions, then you have to use product rule in order to solve that. So what's the difference is just that the function in the equation. For example here, in this topic, we focus on the hyperbolic functions. So we have to use the derivative of the hyperbolic functions in order to solve this problem. Okay, so I'm going to show you two methods in order to solve this. The first one is chain rule, okay, and the second method will be the normal one, which is power rule. So it depends on your suitability. If you feel that it's easier for you to use chain rule, then you just use chain rule. And if you just want to directly solve this derivative, so you can just use that way. Okay, now for chain rule, what you need to do is you have to denote the most inner function. Okay, let's say we denote this as u. So the du over dx will be equals to 2. So now the outer function would be equals to y equals to sine hyperbolic of, so 2x minus 5 now becomes u. So our dy over du would be cos hyperbolic of u. Therefore, to find the dy over dx, it will be dy over du times with du over dx cos hyperbolic u times with 2, and then we will get u, which is 2x minus 5. So that's how we solve using chain rule. Okay, the next one is using power rule. So power rule means we just have to directly solve the differentiation. So dy over dx, so what you need to do is you have to differentiate the most outer function first, okay, and remain the inner function. Okay, for this one we have two functions. The first one is the hyperbolic function and the second one is the algebraic function. So we should differentiate two functions here. So the first one is differentiate sine hyperbolic. It would be cos hyperbolic, and we have to remain the function inside of the sine hyperbolic here. So just remain 2x minus 5. But then, please remember to differentiate the inner function, which is 2x minus 5. Okay, so now we get cos hyperbolic 2x minus 5. And differentiate 2x minus 5 will equals to 2. So your answer is this, where this one is also the same like using chain rule. So both methods are acceptable. Okay, moving to the next question. Here we have y equals to cos hyperbolic cube x squared minus 3 square root. Okay, so now I'll just rewrite this where I represent this function into this form. So here we have x squared minus 3 to the power of half and cos hyperbolic to the power of 3. So here we have three functions. The first one is this one, second one is this one, and the third one is this one. Alright, so now using the method of chain rule, we denote the most inner function as u, which is x squared minus 3 to the power of half, where this would be du over dx equals to half x squared minus 3 to the power of negative half. And then you have to differentiate the inner function, which is 2x. Simplifying this, you will get equals to x over square root of x squared minus 3. Okay, now we denote the second function, which is v equals to cos hyperbolic of u. So dv over du would be sine hyperbolic u. And the third one is y equals to, so all these function cos hyperbolic ni is denoted as v, so it would be v to the power of 3. So dy over dv, it will be 3v squared. So now we can solve our y. Dy over dx would be equals to dy over dv times with dv over du times with du over dx. Substituting all the function, so you get 3v squared sine hyperbolic u, and the last one is x over square root of x squared minus 3. So we substitute back all the values of u and v, and here you will get 3 times with v, where v is cos hyperbolic u, where u is square root of x squared minus 3 sine hyperbolic of x squared minus 3, and then times with x, so I just put at the front, over x squared minus 3. So this would be your final answer. So now using the second method, which is power rule, so I'll just rewrite this back. Okay, so I will write this in terms like this: x squared minus 3 to the power of half, and then to the power of 3. So the whole function is to the power of 3. So now we find the dy over dx using the power rule. So the first one is we have to find the derivative of this power, and then the second one, find the derivative of cos hyperbolic, and the last one is this. So now, for the first one, it would be derivative of to the power of 3, it would be 3. Remember to remain the inner function, so just rewrite back x squared minus 3 to the power of half square. Okay, then we have solved the first, the outer part. So what we need to do is to differentiate the inner function, which is cos hyperbolic of x squared minus 3 to the power of half. Okay, so rewriting this back, so I just write it as this. Okay, so now we have to differentiate cos hyperbolic, where it would be sine hyperbolic of x squared minus 3 to the power of half, where I just remain the inner function. But then we have to differentiate again the most inner function, which is x squared minus 3 to the power of half. So now find the derivative of this. It would be half times with x squared minus 3 to the power of negative half, and then you still have to find the derivative of x squared minus 3, this one. So it would be 2x. 2x. Alright. So we have complete this, so we can simplify this. It will be x. And then now I'll just rewrite this sine hyperbolic x square minus 3. And then cos hyperbolic square x square minus 3. And the last one is over x square minus 3 square root. And the last one is times with x. So this will be our final answer. Now we move to the last question. Y equals to square root of cotangent hyperbolic of 5x. So I just rewrite this into this form. Alright, so now here this is the same example from the previous slide, where here we have 1, 2, and 3 function. So using the chain rule, we denote the most inner function as u. We have 5x, so du over dx will be 5. Okay, then we denote v as cotangent hyperbolic u. So dv over du would be negative cosecant hyperbolic square u. And the last one is y equals to v to the power of half. So dy over dv is equals to half v to the power of negative half, or 1 over 2 square root of v. Therefore, dy over dx would be equals to dy over dv times with dv over du times with du over dx. 1 over 2 times with dv over du times with du over dx, which is 5. 5 over 2 square root of v, which is cotangent hyperbolic of u, which is 5x, and then times with the negative will be at the front, cosecant hyperbolic square u, which is 5x. So make sure that all the answers must be in terms of x. Okay, so now the last method using the power rule. So here dy over dx will be, for the first one will be differentiate this. It will be half, and the inner function will be remain. Then find the derivative of inner function, which is cotangent hyperbolic of 5x. So I just rewrite this back. It would be cotangent hyperbolic of 5x. And then the derivative of cotangent hyperbolic is negative cosecant hyperbolic square of 5x. Okay, and then the next step is to find the derivative of this inner function. It will be negative 1 or cosecant hyperbolic square 5x over 2 times with the derivative of 5x will be times 5. So this will be the answer for this question.